When writing code, you'll often use variables to contain numbers. For example, here is the sketch where I modified the blink program to have it blink out SOS in Morse code. And I didn't use any variables. I just copy and pasted the statements that were there. So let me show you how I improved this using variables. Well, first, let me show you some of the problems with this sketch as it is. Let's say, for example, I want to modify which pin is flashing. So right now this is flashing on pin number 13. So if I wanted to change that, well, it uses LED built in, which is a variable defined. I'd have to change the number here every time. Say if I wanted to use pin 8, I'd have to change every one of these. It's about 20 times I'd have to change that to pin number 8. And what if I wanted it to go a little faster or a little slower? Well, that's controlled by these delay statements. So for the S, where it's the short dot symbol, it's kind of a short 300 millisecond delay, and then for the O, it's a 900 millisecond delay with a 300 millisecond delay when the light is off. So I'd have to change all these numbers, and then what if I didn't get it right? I'd have to try it again and again. So let me show you the new and improved program. Let's go here to here's my program using variables. Now this time I defined a variable called pinFlash that I set to number 13. So if I want to change it, I change it once, and then where I've used it down below, I use the word pinFlash. So when I change the value up here, every time I use the word pinFlash, right now that fills in the number 13. But if I change it to 8, you don't see any difference here, but pinFlash is like a bucket that contains the number 8. So I would change it in all 18 or 20 places where it's used. Another thing I did is the length of the dot flash I defined as an integer. And furthermore, I defined a variable called words per minute. How fast is this thing going? And then I used a little computation that the dot character uses this formula. So when words per minute is faster, the dots is a lower number, so it's a shorter duration. And similarly, the dash, which in Morse code, let me show you. Oh, I don't have it. Let me see. Yes, I have it up somewhere. Here it is. So in Morse code, there's a certain timing sequence they use. Whatever the length of the dot is, the dash should be 3 times as long, and then the space between words should be 7 times, and the space between, like the dots, should be the same space, but between the S and the O should be like 3 units. So by using, actually I'll show this here in Tinkercad, kind of the same thing. So when I use these expressions or these variables, when I change words per minute, then I can compute, okay, the dash equals the dot length times 3, and the symbol space between each dot or dash is the same as the dot, but the letter space, for example, between the S and the O should be 3 times, and then the word spacing is 7 times. So to change this, I could very easily change this number. So let's show how this works here. Let's just look at this If I simulate this, okay, that's how it's flashing now. And say if I wanted to make it go faster or slower, so let's make it go a lot faster. Let's put a 10 in there, 10 words per minute, and simulate that. So now it's flashing a lot faster. And it changed all of the delays, the dot length, the dash length, the space in between. You can see how much easier that is. Or say, for example, if I want to change this to work on pin number 8, I just put it down there, and in my code at the top I can just change this to number 8 in one place, and that changes it everywhere. So I start the simulation. Now it's flashing faster and it's using a different pin. So you can see how much easier this is when we use variables. So before I get too far into this, you ought to set a bookmark to the language reference section for Arduino. Now where I get to this, for example, if you go to Arduino.cc, now I've lost it here. Okay, here it is. At the top here where it says documentation, I want to go to reference, and then I'll make that a little bigger. So this reference section is kind of arranged in 3 sections. There's functions, and now for functions, you've seen functions before, but we hadn't really called it that. The setup part of the code is a function, and the loop part of the code is a function. And in fact, when we use the delay command is also a function by itself. And then the serial communication was a function. So we've used functions. But there's a lot more you can do with functions, and you can write your own functions. If there's a piece of code you want to use several times, you could write a function and then kind of set that aside and call that function when you need it. So another section here in the reference is variables. We're going to talk about variables this time. Now just to show you, there's all different types of variables called the data type. We're going to talk about integer type and floating type in this video. We're not going to go into all of them, but you'll get the idea of how variables are used. Just one other part of the reference section is a thing called control or structures. In the next video, we're going to talk about how to make a loop, maybe using what's called a for loop. So we'll get to that next time. Actually, the loop and the setup are also part of the structure of the code. So I just want you to show you this reference section in Arduino, because you're not going to remember all this stuff. You're going to want to be able to look it up. All right, let's go over some of the basics about using variables. So one of the first thing you got to know, let's say I'll use this right here in Tinkercad, is I need to define one of the data types. Now I said in this particular example, we're going to use integers, and they use int to define an integer variable. And for a floating point number, say that needs a decimal point, we use the kind of variable called float. Let's see, maybe would it look bigger if I... Yeah, a little bigger that way. So for example, words per minute can be between 4 and 5. I could have 4.5 words per minute as a rate. So that I want to use a floating point variable. But all the other stuff, an integer is fine. You know, if it's going to be 200 milliseconds, I'm not going to use 200.5 milliseconds. So an integer is plenty good enough. And for the pin that I'm going to use, well, I'm going to always use an integer. I'm never going to I'm never going to connect the wire to a pin 12.5. It's 12 or 13. So for the pin number, I'll always use an integer. So that's one thing you got to know is about the data type of a variable. Another thing you got to know about a variable is you have to define a name. So notice for the pin, I named it pin flash, or that's the pin that's going to flash. Now you like to use these, name them something that you can remember. So there's no limit on how, like how many characters. You don't have to limit it to 8 or something. So use a descriptive name. And now another thing you got to be careful is that you got to be consistent. However you name this, uppercase, lowercase, you have to use it exactly the same way every time. Now a convention that's often used is this thing, what's called Camel Case. That's a kind of a funny word here. But let me show you here. Here's a picture in Wikipedia what they mean by Camel Case. So if you use multiple words, it's all lowercase except for when you change words, use a capital letter for the beginning of the next word. That's just a coding convention. It doesn't have to be that way. It's just you look like a cool programmer if you do it that way. Go back to my program here. So to use a variable, there's a few things we have to do. The first thing we have to do is we have to what's called declare it. I can't just in the middle of my code somewhere say, oh, I'd like to set the dot variable equal to 100. It says I don't know what dot is. So you have to declare it. So this statement here, I'm saying I'm declaring a variable named dot with the type integer. Now the first time you set a value into it, you're initializing it. Now we can do them both together like this when we say int pin flash equals 13. So this int statement is declaring that this is a new variable and there's its name, and I'm assigning a value to it all at the same time. So there's kind of two ways. You can just declare its name, and then later on we can just use that name. So here I say dot's going to be an integer variable named dot, and down here I'm going to say I'm going to assign a value. Now the equal sign, what that really does, it assigns a value. So whatever this expression equals, I'm going to put that value in as dot. And then whatever dot is, I'm going to multiply it by 3, and the dash is going to be assigned to that value. Not to the name, but to the value of that container dot times 3. Let's see, another thing you need to know is where you declare these variables is important. So notice that loop, for example, is what I called a function. We haven't really talked about that much yet. And also setup is a function. So it starts here and ends here. Everything here is the setup function, and everything from here down to here is my loop function. So if you declare a variable within a function, it's only known within what's called that scope. Unless what I do instead, these variables I defined before the setup. So it's outside of a function. That's what's called a global variable. So when I define it this way, both the setup and the loop know what that is. So for most of the time for my simple programs, I'm going to declare these variables or define them above the setup, so that I can use the variable both in setup to compute a new value, and then I'll use it down here in the loop. Okay? So that's about about it for variables. Just to kind of review, you have to declare them ahead of time. If you don't, it's going to give you an error. So let's try something here. Let's misspell this. What if I had spelled this with a capital D, and I try to verify this code? It's going to say, oh, down here, and it's showing me the line. The first time I use this dash was not declared in this scope. So the scope here is within the loop. I'm trying to use a variable named dash with a lowercase d within the loop, and it doesn't know what it is. So that's what this error message when it says dash was not declared in this scope. So it may seem annoying when you get these errors, but consider that your friend, because what if it didn't give you an error message and it just went on and did the wrong thing? It would be really hard to find that you had made this mistake. So you'd rather know you have a mistake rather than have two variables with a different name and they're not matched up. So you really want to get these mistakes out before you try to run the code. Okay, so we must declare these in the right scope. Usually at the top of the program, we define a type, which is integer, and we give it a name when we declare them. And like I said, for most of the programs I write, integers and float will give you about all you need. That's integer numbers and floating point numbers where the decimal point can move, or I need a decimal point. And I've talked about when I put them up front here, I'm making them global, like globally available, not just within a function. And then another term we use when we use an equal sign, we're doing what we call assigning a value to the variable. And then when we use the variable, we put the name in. We don't put the value of it, we put the name, and the name is like a bucket that brings along what the bucket contains. So it's like a suitcase, and here's the value of what's inside the suitcase. And remember, like I showed you, it's got to be exactly the same. And then notice that I use what's called Camel Case. And you don't have to do that, but it's just a nice convention that most people who write this kind of code use. So symbol is all lowercase, and then the first letter of the next word I used an uppercase S. Well, that's about what you got to know about variables to use them. So in the next video, we're going to combine some of this stuff, and we're going to use maybe a serial print along with variables, and then we're going to put that inside a loop. We'll talk about the structure of a for loop next time. Okay, so let's I want to play with this, but I'll look forward to seeing you in the next video.